service if I wanted to. So there's a lot of benefits with using those services there. Okay, so what about if I want to offer something to the internet? Maybe I'm running a web server. Well, I could give it an instance level public IP. We know that sucks. We don't want to do that. More likely, I'm going to put it behind a load balancer or an app gateway. Maybe an Azure firewall, but Azure firewall is really not designed for that type of balancing and that type of offering resources. Maybe there's some other network virtual appliance. Maybe I don't want to use the Azure native functionality. Maybe I'm using an Nginx or something. There are other solutions to do that. But saying it's going to offer a service on the public IP and then distribute it to multiple backends. Be careful about what ports you expose to the internet. We're going to come back to that. So, if this was about getting outbound to the internet, well, now what I want is from the internet to be able to talk to my service. And so I have to have a public IP. It can't talk to my private IP from my VNet. Again, I could do instance level. I do not want to do, we'll draw it in, so this could be instance. I don't want it. It's horrible. So what's the problem with doing an instance level? It goes directly to a particular resource. So firstly, I've got no opportunity to add any kind of protection in front of it. The only protection is going to blindly send everything. Now, things like distributed denial of service, there's native protection at the VNet to stop huge scale distributed denial of service types attacks. There's also a standard distributed denial of service I can add now. It would be more specific, it would be more tuned, I could do more reporting on it. But outside of that, everything just gets passed straight through. It would be nicer to have something to be more specific about what it's going to pass through and when, and maybe even add like web application firewalls to do some checking. Hey, am I trying to do a SQL injection attack? Am I doing something bad? But also, it's going to one resource. If that resource is down for maintenance, I've only got the scale of one resource. I probably want to have multiple back-end resources so that I can distribute the workload. And so what I really want to think about owning this public IP is some kind of load balancer. Now remember that load balancer might be providing the outbound as well. It's a standard external load balancer. And then what I do is I have a back-end set that would have all these members in it. When it gets to request, because the public IP is bound to the front-end configuration of the load balancer, and this is the back-end configuration, it's doing health probing to say, hey, are you there? Only if you're healthy, we'll actually send you stuff and requests. But it could do checking. Now, there are different types of load balancer. So remember those layers again? So layer 4 would be just the regular load balancer. Understands TCP, UDP. I can have a certain amount of stickiness. Stickiness is, well, if a request comes in, do I always send it to the same back-end member? So there's 5 tuple by default: source IP, destination IP, source port, destination port, protocol. If all 5 of those things match, I'll go to the same instance. Maybe the port changes. Maybe the protocol might change. I can do things like 3 tuple. So in 3 tuple, it doesn't care about the ports. It just cares about the IPs and the protocol. I can do 2 tuple, doesn't care about even the protocol. If I do 2 tuple, the ports can change, the protocol can change. As long as the source IP and the destination IP are the same, it would go to the same backend instance. But it doesn't understand a higher level things like HTTP or HTTPS. It can't. Inspect the traffic, can't do cookie-based affinity. Well, that's what App Gateway does. So the other option is App Gateway. It understands layer 7. It can provide those additional features. And if we actually jump over and look at the portal for a second, we'll just go over to here. If we just search for load balancers, there's many different types. But if you go to this overview tab right here, it will help you decide. It has a little set of questions. And it's telling me the different types. Now, ignore front door and ignore traffic manager. These services, we're not actually really going to talk about this. We talk about that more in the resiliency. When we talked about resiliency, I talked about front door and traffic manager. But they are global services. Front door and traffic manager will distribute between instances of some regional service. I want to focus on App Gateway and the load balancer. And it's telling you, hey, layer 4, layer 7. But But instead of looking at this questionnaire, I can just do a service comparison where it's telling me. And it tells me, well, App Gateway, hey, look, It's HTTP, HTTPS, HTTP2, whereas load balancer is TCP and UDP. It tells me how it can distribute, what can be supported. So load balancer can only point to Azure services. Whereas what we can see is, if I go and look at my app gateway, my app gateway can actually point to Azure and non-Azure and even on-prem things. So it has more flexibility. And then there's some other capabilities, but notice because App Gateway is layer 7, it can do nice things like TLS offloading. So it's got some nifty things. It can do web application firewall, whereas a regular load balancer can only do NSG. So there's different benefits I get, but I can go through this, but realize the real big difference between these is what does it understand? So that's the whole point. And so just to make it super clear, so the whole point of then these are regional. So these solutions here are regional. They're providing, and they've got to be careful when I say that. The service itself is in a region. Now, as we saw, App Gateway could technically point to things anywhere it wanted to. But the App Gateway instance lives within a particular Azure region. So if that Azure region was down, that App Gateway would not be reachable. But then there are global solutions. And at the layer 7, that would be front door, Azure front door. Layer 4, well, there's actually the global load balancer now. But then there's also DNS. So there's traffic manager, which is DNS based. So really would work across any type of service you wanted to. And the whole point is you'd have these global solutions. So maybe I've got an Azure front door, for example. So this is my global. And then what it would actually point to are regional solutions. So since Azure front door is layer 7, so HTTP, HTTPS, at the regional level, I would have App Gateway instances to then go and talk to some web service. It could be containers, it could be Azure App Service, it could be VMs. But that would be how I would make that distribution. So a global service, a regional. If instead these were not app gateways, if they were just standard load balancers, I probably wouldn't use Azure Front Door. Maybe I'd use Traffic Manager. And it's DNS based to distribute between them. Or I could use the global load balancer, which is also layer 4. So we have different architectures depending on what are the services we're actually using. So that's how I can talk to the internet, offer things to the internet. That's how those things work. Okay. Do not enable RDP or SSH or WinRM to the internet. It's a great way to test how good your passwords are because they're going to get hacked near instantly. If I have to offer it out to the internet, at minimum, use things like Defender just in time. What it will do is it will lock down the rules that enable communication to it so that it can only come from your IP address for maybe 2 hours. Or I could use something like Azure Bastion. Azure Bastion is a managed jump box and it can do authentication using things like Azure Active Directory. So I would actually go and talk to the managed jump box service, which then I would go and talk to the resource within the virtual network. And I could use those together. There's different ways I can do it, but don't just go and open up to the internet. And that's a super common pattern. So if I do want to actually be able to RDP to my services, well, let's say there are those resources there. In an ideal world, remember, I'm sitting at some office somewhere. So let's say this is my office. And in my office, I'm sitting there on my machine. The best case scenario is I've got a link between my network and Azure. Because then I can just RDP or SSH to the private IP that it still has of the resource. Great. I don't have to go via the internet at all. But if I don't have this link, if I have to go via the internet, then, right, there's different things I could do. This is where Azure Firewall can do DNAT. So Azure Firewall has an IP address that different ports can go to different internal resources. Or if it does have an instance level, I go into Defender, I do it just in time, say, hey, I want to connect from my IP for 4 hours. It would open up a rule to allow this instance to work just from my IP, just for 4 hours. Azure Bastion lives in a certain subnet. But it can work for peered networks as well, where I, through the portal or through the native tools now, connect via the Bastion, which has a public IP, and then it acts as that managed jump box service, so I don't have to do it, and then I go and connect to my resource. A jump box, I'm assuming, is a familiar concept. The idea would be, if I manually did it, I would create a VM. So I would create a VM, and I'd call it jump box. And that jump box VM would have a public IP. So what I would do is I would first RDP to the jump box. I'm now sitting on this machine, and then I could RDP to the private IP address. So I'm jumping via that box to my target resource. But I have to be super careful about locking this down and protecting it. So Azure Bastion is a managed version, but it's much, much better. So that's available to you as well. So that's a useful thing to know about. Okay. For the public IP addresses, normally you're taking them from Azure. Azure has a huge range of public IP addresses. It makes them available to you. And you could not bring your own. They have now made it available, so yes, you normally would use theirs, but you could bring your own now if you really wanted to. Now, the minimum size I can bring is a /24. That may seem really small, but public IP v4 addresses are pretty scarce. So I have to bring an entire /24 to Azure. And the reason is, remember, what is the internet again? The internet are connected routable networks. So anytime I add some address space, now the entire internet, really that works, but they need to know how to get to it. So I don't want to do onesie, twosie IP addresses. The route tables would get hideous. So instead I want to be able to summarize. So Azure will now start offering out, say, hey, if you're trying to get to this range, I'm your target. And again, there's different hops along the way. They aggregate tables. So I don't want to offer a /32 one IP address. So the minimum is a /24. So I can bring my own set. There's a series of steps to do this. It's a multi-stage process. Firstly, we validate, then we provision, and then we commission. So the validation is checking you actually own that range of public IP addresses. So it has to be registered with some standard routing, internet registry, ARIN or RITE. You're bringing it. Then you provision it. So this is now going to be a prefix within Azure, an IP prefix. You then take IP addresses from that and give them to resources. It will, anything that supports the standard SKU public IP will be able to now use this IP from this prefix you've brought Once you've done that and you're ready, you're going to commission it. When you commission it, what you're doing is now saying, Azure, I want you to start advertising that you have this range out to the internet. It's going to take a while. Azure has to say, hey, this region has it, and then the Azure backbone, the WAN, has to say to the internet, hey, we have it. So there's going to be some time it takes to propagate. gate out, but now those services are now being offered from you. So you've brought your own IP range to Azure, and it's offering those services. So if you really want to, for some reason DNS isn't good enough, I want to bring something to Azure and it has to be within this particular IP range for some reason, well, you can now do that if you have to. So I can bring my own IP range. Okay. Connecting virtual networks. Remember, if I have multiple subscriptions, if I'm using multiple regions, I'm using multiple subscriptions and multiple regions, those two things. Things are the boundary of a virtual network. It cannot span those things. So I may end up with multiple virtual networks. In the past, there were ways to connect virtual networks, but those ways, they were ugly. So let's look at what those ways were super quickly just so we can see how bad they were. So we're going to start drawing under here. I've got two virtual networks. So I've got VNet 1 and I've got VNet 2. Let's say they were actually in the same region. So let's say they were both, they don't have to be, this doesn't have to be the case for this, but it helps show why this is bad. Let's say this was in South Central US, which remember means they're in San Antonio. Okay, and let's say in our example, we want to use our ExpressRoute. Now ExpressRoute is a private connection, we're going to talk about this, but the way ExpressRoute actually works is there's a Microsoft backbone network, which these basically get connected to because they're going to have a gateway in each of them. And then what happens is there's something called a meet me, a peering point. And normally this is where I would then connect my network to it, which will then connect to here. All the Microsoft backbones connects. So I might say, hey, I want to connect my two VNets together by connecting them to the same ExpressRoute circuit. That sounds fantastic. They're in the same data center, it's bound to be super quick. The path the traffic will flow is to the meet me. This meet me might be in Dallas. So even though the servers that are being spoken to each other might be sitting across the data center, they can see each other, they can wave. If I connect them to the same circuit to connect the VNets together, it's going to route hairpin via the meet me location, which could be hundreds of miles away. The latency will be horrible. I don't want to do that. So we're going to do our big red pen. This is a frowny face scenario because latency. I mean, all other regions as well. Latency, I'm wasting the throughput of the circuit. This is just a horrible thing. Okay, we said ExpressRoute, that's not a good fit. What about a site-to-site VPN? I have exactly the same scenario. I have exactly the same, I have gateways, but this time they're site-to-site VPN gateways. And I'm going to establish a site-to-site VPN to connect them together. Well, remember, how does a VPN work? It encrypts the traffic, expecting it to go over the internet. Now, these wouldn't go over the internet because they're both in Azure. Even though it might be a public IP, it would stay on the backbone network, but it's still using IPsec. IPsec is expensive in terms of computational resources to do the encryption and decryption. So what here is throughput. Is going to be bad. So this is not that great either. So my throughput, the amount of bandwidth is going to be limited by whatever the skew is of the gateway, because that's how big its CPUs are, that's how much traffic it can do. So I don't want to do ExpressRoute to connect VNets together, I don't want to do site-to-site VPN to connect virtual networks together. So what do I do? What is my answer? VNet peering. So VNet peering enables me to, on the Microsoft backbone, just connect virtual networks together. They cannot have overlapping IP ranges, but they can be in the same or different regions. It does not care. There is a small today ingress egress charge, so I pay for the data going out, I pay for the data coming in, so there is a fee that I'm going to pay for that. And again, the IP address space cannot overlap. So what this now would look like in our picture is, okay, we'll draw the same idea of, I want to use this picture for some other stuff as well. So we'll say this is VNet 1, this is VNet 2, and I'm just going to peer them. And again, there's global VNet peering, there's just regular, which would be in the same region. It doesn't really matter, but now this is just going to work. So we'll give this a smiley face. This is the best option to connect things together. But again, when I'm doing this peering, what I cannot have is no IP overlap. They cannot use the same IP addresses. I cannot overlap them. But I can obviously connect multiple VNets together. We'll have this VNet over here as well. So we'll call this VNet 3. These can peer. Great. Can these talk? This is a very common model, a hub and spoke. Here's the hub, these are spokes. Can the spokes talk? No, they can't. It's not transitive. So if I wanted these to be able to talk, I would have to explicitly add a peering relationship between them. That's how I could make them actually be able to communicate with each other. Now, It can span subscriptions, it can span Azure AD tenants, but it's not transitive, but they can be. What does that mean? By default, they have no way of talking via the hub. This is the hub, although they're both connected to the hub, there's nothing in the hub that will take a packet from here and send it to the here for them. This VNet has no reason to think, oh, I should send it to the hub, VNet 1, to be able to get to that. Why would it possibly think that's the thing to do? Well, what I can do is let's take out this here. I could add in this hub network, I'm going to call this a hub, because it's a very common pattern to want to do this. I could add maybe Azure Firewall, or just a network virtual appliance that does forwarding, that can accept a packet and send it somewhere else. But I still need to tell this VNet, hey, if you want to get to VNet 2, now this, whether it's a network virtual appliance or Azure Firewall, it's going to have an IP. So let's say this is IP 1. I need to tell this, hey, if you're trying to get to VNet 2, your next hop, so the place to send your packet, is IP1. And likewise, this one needs to say, hey, if you're trying to get to VNet 3, your next hop is IP1 as well. Notice something nice about this. The next hop doesn't have to be in the same subnet, even within the same virtual network. There's really nice things that we can do because it's software-defined network. Normally, I could never do that. The next hop would have to be in the same subnet. It doesn't have to be the case here. Hey, next hop is this appliance over here. Now, how am I doing this? How am I defining to say, hey, when you're trying to talk to this IP space, which is the side of range of VNet 2, this is your next hop? Well, the solution is something called user-defined routing. So what we're doing is we're creating
doable, or just pass on like this. That is also doable. That is how you're using. Convert that. Okay, moving on quickly and fastly. Don't want to drag down the tutorial. Okay, let's just say I create another function which is going to be simply a sign up. So I'm going to go ahead and say sign up user. So let's just sign up the user. Now for this one particular one, I'll just define the definition like this. And I want to have a couple of more parameters in this case. At the time of sign up of the user, let's just say I'm going to ask him for a name. And I'm going to go ahead and ask him for email, and I'm going to ask him for password. Pretty common thing. You have seen this 1,000 times. Now, why this is particularly bad in this case, because I can simply go ahead and say, hey, I'm going to go ahead and have a user sign up. If I go ahead and go like this, obviously it complains that, hey, there are squiggly lines, so that means you have to pass on. But all of these are marked again as any, although there are 3 parameters this time, but they are being marked as any. So I can go ahead and say, hey, 1, 2, 3. You should be all happy because it's any. And that defeats the purpose of having a TypeScript. So in these cases also, individually, and this is the syntax how you do it, this one is a string, and this one is also going to be a string. And since everybody is a string, let's change this one. So this is going to be is paid. So just to have a flavor of it, this is going to be a Boolean. So in this case, we are going to go ahead and have a Boolean value. Pretty simple, pretty easy. So that's it. Now right now in our function body, there is nothing in it, but you get the idea. You have watched the JavaScript, the code part and everything, you can write that. This is a series more about focusing on the TypeScript. So now we see the squiggly line complaint, but other guys are not complaining. And this is the one thing I absolutely like about the TypeScript. So fix one error at the time. This is updated in the recent version of it. So I go ahead and say, hey, you need name. I'm going to go ahead and give you a name, probably my name. Then it says, hey, this is also incorrect. Argument is number, but it should be a string. So let me go ahead and change this one. So let me go ahead and say Hitesh at lco.dev. And this one also needs to be a Boolean. So is it a paid user? Nope, it is a freebie. So there we go. Now it is all good and okay. Now one more thing that I want to cover in this video quickly is another method, and then I'll tell you about the problem. So let's go ahead and actually use different kind of function this time, an arrow function. So let's just say we're going to have a simply let, and this time login user, and we can just go ahead and use the arrow function. The definition remains same, so I won't be writing anything inside the curly braces, but the value which we are worried about is how to take the input. Let's just try to have simply email and is paid. Let's just say these are the things. So I'm going to go ahead and worry about email, probably name also. Let's just say name, email, and again is paid. We are using same parameters. Now this is good. This is good. There is no problem here. But let's just say I only want to pass on two values. Obviously these kinds of cases will come up here. So in the name I can go ahead and say, hey, this is going to be a string. The email is going to be a simple string, and the paid is going to be a simple boolean. But one syntax that might confuse you: how can I pass on default values? Let's just say in the case of login user, I want to use this and I want to simply pass on just two things, maybe name and email. So name is going to be h, and the email is going to be h@h.com. I wish I got that domain, but I don't want to pass on other values. Now when I save this one, notice here login user, it is not giving me any complaints as of now. Let me go ahead and try to run this one. And there we go. I told you my system is a little slow today, but just giving the idea that yes, this is paid is a compulsory thing. It needs to be there. And one way you can have an avoidance of this one is simply by providing a default value. The syntax goes, first you annotate it, colon, and then the data type. And then you simply go ahead and say, hey, this is going to be false by default. And now the system is happy, not because it is slow, it is truly happy. I can go ahead and run the code and I can see that, hey, this was all okay. And this is the brief overview of it. And yes, it generates the equivalent of the same exact, almost same code. But notice here, some code was generated a little bit more in the login user. This is the most important part where we should be focusing a little bit. Now, obviously, this is generating us var as a keyword. We can update the tsconfig and learn about that later on. Please ignore that as a moment. And right now we can see that there is a name, email, and is paid, and we are looking for a conditional check. If is paid is void, then it is 0, otherwise false. You get the idea. TypeScript helps us to write a little bit of a cleaner code, as a stricter code in that case. So this is all about it. But one thing still is remaining, which is, hey, if you look at this example closely, add to is a number. That is great and fine, and maybe we are holding that value and further doing an operation. So for example, let my value that is going to be holding by add 2, and I'm expecting that the value is going to be added to 2, so 7 value. But what instead of this, I go ahead and return not just like that. So let me just comment this out, and I go ahead and return a simple something like hello. Nobody's stopping me doing that. So we need to learn that, okay, this is completely stored and completely fine, and yes, my system is not slow. This actually is allowed right now. So we need to worry about one more thing about the functions, which is how can I return more accurate value? And that's going to be coming up into the part 2 of the TypeScript function. Go ahead, hit that subscribe button. I'll catch you up in the next video. Hey there everyone, Atesh here, back again with another video, and welcome to the TypeScript series. So in this series, we have already discussed a tiny bit about the functions in the last video. And as I promised, this is going to be the final video on the promises, and you'll have enough of the knowledge of how to handle functions. Now the TypeScript revolves all around the types, and you will be learning a lot about the types as we go further. It's not like just these are the primitive types, these are the types, that's all you go ahead and do with that. It's more about the philosophy of how you use the types, where it is necessary, where you can avoid them, and all of that. That is what we are going through with this series. Remember, TypeScript is just a superset or a wrapper around the JavaScript that allows you to write better JavaScript. So I hope you have watched the entire series or playlist. And in case you haven't yet, go ahead and hit that subscribe button, and let's go ahead and get started with that. So taking you again onto my computer screen, so this is what we have done in the last video. Now, while discussing all of this in the last video, we noticed that we were returning, instead of a number just by adding to it, we were returning hello. And this was not giving me any problem at all. And this is a point of concern for me. Especially try to always imagine, whenever you're learning TypeScript, always imagine that this is not just you who is writing the code. This is a team of 20 or maybe 30 developers who is writing the entirety of the code. You have defined some function, maybe somebody wants to add his own functionality of the function, and now if he's going to do such things like return hello, obviously this will break your entire application, because there are probably 1,000 use cases of this simple method which are dependent of returning a number to it. But since you change that and you're returning a string, that can crash your entire application. It is a little bit debugged to handle the things in 20 or 30 or maybe 40 developers of a team. So that is why TypeScript is being used in the function. So obviously this is making a problem, but TypeScript is not giving me any error or at all. So that is why we have learned about that at the time of taking the input, we can annotate it with by whatever the type you want to accept. And similarly, you can just put a colon and can say that, hey, this is add2, this is supposed to return me a number. Now, as soon as I do this, this will allow me to not do such things, which is just a mischief activity that, hey, instead of returning a number, why are you returning a simple hello, which is a string? You shouldn't be doing that. So I can comment this out and I can remove this comment and can say that this is happier now, much more happier. This saves me a ton of time and my team's time to write productive code and make better softwares. Okay. Moving on, let me talk and discuss a little bit more about the functions, and then I will redirect you onto the documentation to understand that yes, there can be more with the functions, but this much of the knowledge is enough, good enough. Okay, moving on. So let's just say first and foremost, let's talk about some of the functions which are going to be like this, and again, we'll talk about them a little bit later on. Right now, just want to give you a brief overview of this. So for example, let's just say there is a simple function which says get value. There is nothing wrong in it. And in this one, you simply say, hey, give me a my val, just like this. And this could be anything, number, string, doesn't really matter. Let's take our example with the number itself. Now, you're doing some conditional check, maybe just with the if condition, something like this. If my val is greater than 5, then I would like to simply go ahead and say, hey, I would love to return something like true. Maybe there's a use case scenario for you in this one. Otherwise, if that's not the case, you're going to go ahead and say, hey, return a status code. Maybe you're building a web application which says 200 OK. Now, in this case, obviously, our first theory is not really applicable, because if we go ahead, right now you can see if you get hover onto this one, this says, hey, this is giving some hint that it can be either a true or can be a string, but we are not explicitly mentioning that it can be a simple, let's just say if I do ahead and string, then this gives me a problem. If I go ahead and say, hey, this is a Boolean, then this gives me a problem. So we haven't yet learned about the type where we can return more than one type. So just want to give you a brief overview that these kinds of scenarios will happen. These are part of functions, but we have to learn a little bit more about TypeScript in order to handle these situations. Not really complex, it's just a union type, and we'll discuss on that in a separate video. So just giving you that, yes, this could happen. This is one of the case. Okay. Moving on, there are a couple of more things that you can do. For example, let me take another example so that you can take these code file as a note one. So let's just say there is simply a hello, and this is a simple method. Or let's just use a arrow function method, because I think you would also love to know that if here we can put up a colon and number, what is the syntax of doing the same thing in the arrow functions as well. So this is how our basic arrow function works. We have written that many times. So inside here, we take all the parameters, like for example, you want to take a string as parameter, you can do that. Just after these parentheses, you can put up these colon and can say, hey, I'll return up a string as well. Now, as soon as I do this, this actually gives me a problem that, hey, functions whose declared type is neither void nor any must return a value. So this is giving me a problem that, hey, you're not returning me a value. So your code is actually wrong. So in this case, if I go ahead and return even an empty string, this is just working out. So this is the basics of how you do it in an arrow function. I hope you're getting this. I hope you're enjoying this. If yes, hit that subscribe, and a like would be really awesome. Otherwise, let's continue. There is no problem at all. Okay, one more thing I would like to discuss about this is some values, something like this. So let's just say we have some heroes, and you know what heroes I'm about to use. You know me, I'm a big Marvel fan and a DC fan also. So let's just say we have a Thor, we are gonna go with Spider-Man, and we are also going to go with Iron Man. So we have a list or an array in which there could be numbers, there could be string or something like that. Now, one of the great advantage of using the TypeScript is it knows really so much out of the box. For example, this is a common scenario. We do this in like 1,000 times in JavaScript. If there is an array, we go ahead and loop through it by using a map. If I go ahead and use a map, I'm actually looping through each of the hero, and then I go ahead and use a callback. And I can probably say simply, hey, I'm going to return a simple string, something that's going to say hero is, and then let's use a variable which is going to be something like this, and let's just go ahead and have a hero. So this is a really simple code, nothing magical out of the box. But if I hover over to this heroes and this map function even here, you can notice that this is giving us so much of the definition and advantage. I don't have to call anything. It automatically predicts that hero is going to be a type of string because this array is of type of string. But if I go ahead and duplicate this, and let's call this one as, let's comment out this one. And instead of having a Thor, let's just go ahead and say that this is 1, this is 2, and this one is 3. So TypeScript, all I wanted to show you is TypeScript is smart enough. If I hover over this, it automatically changes this hero to a number. So it is aware of the context that is coming up in here. Right now, if I go ahead and uncomment this one, comment this one, it automatically switches its thing into string. So the hero is a string in this case. So I can avoid an additional step that, hey, whatever the values that are coming up from this one, I don't have to explicitly annotate that this needs to be always string. Perfect syntax, I can go ahead and work on with that. But as you know, the context switching of the TypeScript is really smart, and we can rely on this one. So there is no problem in that. So in this case, yeah, it's good. I'm happy with this one. But the one thing which you should be really careful is what is the return type of this method. So in the map, it is expecting that, hey, you're returning up this string here, but instead of this, there might be a case where you want to return in every case too. That is also allowed, and that is also valid. That's why the map has such a detailed information that is given to the TypeScript that, hey, what is the value you want to return? In this case, it could be 2 or it could be a previous value. In this case especially, I would love to return that what is the type of the value that we are returning in this one. Again, we could do it like this, and then we can say, hey, The values that I'm returning is going to be simply a string. There we go. This is much more of a readable and reliable code. So when I go ahead and say, hey, in every case, I'm going to go ahead and do 1, it stops me from doing this. So good practice that we should all follow, that, hey, don't do such thing. Yes, you can avoid that input. It will automatically deduce what is coming up from the array. But this is a better syntax, especially for when you're writing the code in the team. So this is a better. syntax. Okay, this is the basics. Now coming up on to the final part of the function where we actually will move into the documentation. This will actually force us to move into the documentation. So let's just say there is a function we are defining, and there are two types of function. The first one is simply saying console error. So the idea behind this method is whatever is being passed to it, you just go ahead and log it to console. So let's go ahead and log it to the console. Obviously, we have to take an error message. So let's go ahead and call this one as error message. That is a type of string that is being given to us. And we are just going ahead and saying, hey, just go ahead and print this error message into the console log. A very common scenario which you do while building the web application in the initial phase. Now, if I hover this one, it says, hey, the console error, the message it's taking is in the string format, but the colon after this is void. That means it's not returning anything. So yes, this could be the thing. But another, this is not a good practice, especially if you're using TypeScript. The good practice is to explicitly mention that, hey, whoever is using this function, he knows more about the definition of function, that this is returning a void. That means it's not going to return anything ever. So accidentally, it just says that, hey, if I go ahead and say I'm going to return 1 as error message. Now you shouldn't be doing that. And again, this might look like, hey, that's very easy. It's easy because you're just alone coding right now, watching a YouTube video. But imagine when you'll be writing code with along 15 developers or maybe 50 developers alongside with you. Okay, the same thing could be replicated one more type. Another method that you will be handling a lot or writing a lot is handle error. So this handle error, obviously, this is handling the error. This is not going to be returning a void because it handles the error. So let me go ahead and copy some line from the documentation directly, because this is something which is coming up from documentation. I'm not making this up. So just like we have all these things in the documentation under the more functions, this is written as never. Some functions never returns a value. Neither it's void, because void means return nothing, but there is never as well, which never returns a value. That simply means the function never returns a value. I know this is very close to the void, but this is specially made so that you can handle some kind of error, because this is kind of an intentional crash that we are doing to the function for having this. So in these kinds of cases, I can just copy this line and I can go back onto the code, and instead of the console logging the things, I can just go ahead and say throw new error, and whatever the error message I am just passing on, I'm handling this gracefully. So if I go ahead and put this as a void, which is not a good thing. If you want to make your errors more robust and handling part of it, just use never, which is again recommended in the guidelines of the TypeScript. If I hover this again, it says the return type is never and error handle is declared, but its value is never read. That's fine, but you get the idea. From where this is coming up, again, I'm not pulling this out from the thin air or out of a hat like a magic. This is mentioned in the documentation. The never type represent value which are never observed. In the return type, it means that the function throws an exception or terminates execution of the program. So forceful termination of the program. Never also appears when TypeScript determines there is nothing left in a union. Union, we'll talk about that later on. That's a subject later on. But you get the idea how to read the documentation and how to find out the actual source from where this is coming up. I hope you are enjoying this, the valuable series up here. And again, I'll wrap this all the source code from now onwards. I'll put them into the dashboard as a community session, which is a free segment here at iNeuron. You can go ahead and download them, so you can have that. And again, the most important part is not just the source code that I'm giving you. The most important part is the mindset that I'm trying to give you with these videos, so you can write better piece of softwares. That's it for this one. Let's catch up in the next video. If you really think that just by adding TypeScript, you have removed all the bad behavior of JavaScript, that is not the case, my friend. There are some still odd behaviors, even in TypeScript. Maybe in the future version they will go away, but still we have a lot of misbehaves of JavaScript still existing in TypeScript. I'll show you one here. Hey there everyone, Hitesh here, back again with another video, and let's go ahead and get started with the TypeScript series. Before that, hit that subscribe button and the bell icon as well. I would be really happy with that. Now that, assuming that you have hit that subscribe icon, come on guys, 70% of you haven't hit that. Okay, I assume that you have hit that. Now let's go ahead and walk through with the objects. Now again, I won't be consuming too much of the videos, like I won't be releasing 14 or 15 videos on just objects on TypeScript. We'll walk through with the most important part of it, enough that you can get started with that. So there will be a couple of videos on object. Let's go ahead and get started with this one, and I'll walk you through how objects are there and what are the places where it can misbehave just a little bit, and your code might actually get compromised with that. So let's go ahead and walk you through with that. So how does the object works? Now objects are really simple. We use them all the time in JavaScript as well. So maybe you want to make an entry in the database, you collect all the values in the object format, then you pass on this object to maybe a backend controller. It modifies all the things and adds an entry in the database. That is the most common use case scenario. For example, let's just say I want to create a simple user. So this is how go ahead and create an object of a user, and I'll just add more values to it. So for example, if I go ahead and say, hey, this is the name. So whenever I'm adding a value or a user to my database, I'll say, hey, this is a name. Then we got an email. So let's just say hitesh@lca.dev, another email. And I'll also say that if this is active or not. So I'll say if this is an active account or not. Means people are regularly using it. So this is a basic object, and yes, TypeScript syntax is exactly same, and that is where you'll be using it most. But this is not the use case of the object. Designing an object like this doesn't really make sense, and you won't be using it too much. The use case of the object is through the functions. You have to actually pass on these objects into a function, or you have to return some objects through the function. That is the most common use case that we use while developing any application. So let me walk you through with how these are done. So for example, let's just say we are creating a method which says create user, and this is a simple method. Now since this is a forgot the keyword, so function. So this is a very basic method that we have. Now this method expects that you will be passing me some of the user. So the very first syntax is you pass me an object, and I'll define that at least give me a name, and that name is going to be a type of string, and give me another one which is, let's just say, is active, or is Google auth, or what should I do? Is paid. Okay, let's go with that, and that will be a boolean. So this is the very basics of it that we have got. Let me just go ahead and move this up. There we go. So this is the most basics of that we have. Now, well, whatever we return the value, we'll discuss on that. You can return an object, obviously. That is the most basic part and the obvious part of it. Now, what it allows us, when you have a definition like this, then the method becomes a tiny bit more secure. So for example, when I say, hey, I want to create a user, I want to use that, TypeScript actually stops me for doing that, and looks like it is not stopping me. Probably my system is a little slow, so let's just go ahead and say TSC, and I'll say my objects. Let's go ahead and run that, and there we go. We saw an error that create user cannot be used like this. So let me just go ahead and try that. Hey, why are not? Let's try go back up here and come here. No error threads, but you get the idea that this is actually stopping me from doing all these things. And how can I actually get rid of this? By passing on an object. By the way, why this is stopping me to doing so? Because probably I forgot to export. So actually we always have to do, we'll come back onto this part, that why we are actually doing this, because this exporting of the objects is really helpful in this case as well. I will definitely have those values, so please cancel that. And we'll be exporting that. Probably this will start. There we go. We got the errors. I'll definitely discuss this part as well as we move into the React part, or maybe Angular part of it, that how this actually works. We'll surely take care of that. Now, right now, the important part is that when we say create user, it stops me from doing this. So there we go. We can go ahead and use an object. Now it's complaining me that, hey, the object that you have defined, that is exactly the same which is I'm expecting from this method to give me, but the syntax or the following must-have variables are missing, or properties. So in this case, I have to say name, and the name is going to be, let's just say I'm creating a user with the name Hitesh. That is fine, but still I'm missing one, which is paid. So I'm going to go ahead and say is paid, and we'll be saying this is a free user on the platform. So this is a pretty obvious behavior that we have, and this is now probably trying to have my code in a much better way. So this is the most basic of it, and you can actually add a lot more things on top of this. Maybe you also want to define, and one of the syntax which actually makes people a lot confusing is what happens when a function actually returns an object. So that is the most confusing of all. So let's just say you are not creating a user, you are creating a course in this time. So let's just call this as create course. Now this is obviously a function, so let's go ahead and say function, and this is an object. Now this is a return type, and there we go, and this is actually a definition. There we go. Now this is a bit of a weird syntax. We forgot a colon there. Now what this is saying is that, hey, this is a function name, this is a function parameter where you pass on, this is a return type, and this is a definition. So yes, there is a lot confusing up here. The reason why it's complaining is simply because you have promised that you will return an object and you are not returning anything. So obviously you have to go ahead and return this one. This one is happy now. But in case you have a special syntax that I should be returning some things like this, so you can actually go ahead and make it like this. So any course that you are having is going to have a name, and the course should have a price. Again, fictitious scenario, and this should be a number. Now obviously this will complain. This is a better definition of function in case you are having that, hey, this should return me obviously always and always an object which should have these two properties. So whenever I'm going ahead and returning anything from the function, it promotes a good practice and less error that, hey, you should be returning the name. For example, this course name is React.js, and the price is going to be, let's just say, $3.99, something like that, whatever the price is. So this is the basic. of it. And now you know the syntax and the weirdness. This is the only thing which I have seen a lot of people get confused about, that what happens when an object returns an object. Yes, I do agree, this is a little bit of a weird syntax because we have parentheses, then colon, and then this is an object. And the definition, and it gets a little bit more confusing when you have the object in this format, because it's returning these things, and then so these kinds of definition makes people a little bit confusing. Now, what is the odd behavior regarding the objects which comes up in the TypeScript? Okay, that is something really bad.